What I'd like to talk about in this video is how to simplify a square root. So the example that you see, the square root of 18, it could be approximated. If we use our calculator and we type the square root of 18, we're going to get an irrational answer. And rounded, the square root of 18 is 4.24. But there's a better way to express radicals as an exact answer, but they need to be simplified. The square root of 18 is exact, but in order to simplify that, to make it what mathematicians call simplified, there are some steps that you have to take. And that first step is to take the number that's underneath the radical and write it as a product of prime factors. Now you're probably used to seeing product of prime factors being found by using a factor tree, but I actually prefer a method called the ladder method. And so what you do for the ladder method is you take the number in the box and you make a box under it. It's kind of like an upside down division symbol. And then you think of a prime number that will divide evenly into that number. Well, if the number is even, I always use 2 because 2 is easy. It's easy to divide a number by 2. Now, 3 would have also gone into 18, and it is also prime, but I just have a habit of every time it's even, I use 2, just because it's easy to cut numbers in half. So half of 18 is 9, and the 9 goes underneath. But 9 is not prime, and so I have to create another box and think of another prime number that goes into 9, which is 3. 3 goes into 9 3 times. And since 3 is prime at the bottom, you know you're done. So the square root of 18 is actually the same thing as the square root of 2 times 3 times 3. Well, if we were to break this square root apart, we could break it apart to say the square root of 2 times the square root of 3 times 3. Now, the square root of 2 is what it is. It can't be simplified anymore. But the square root of 3 times 3 is the square root of 9, and the square root of 9 is actually 3. So the simplified expression is 3 times the square root of 2. We usually put the number that got out of the radical out front and the radical itself on the inside. And so this seems like a really long drawn out process, but let me show you a shortcut. If we were to take the same square root of 18 and write it as a product of prime factors, what we need to do is look for factors that pair. Because this is a square root, I need factors in groups of 2. So what I'll do is I'll circle the 3's and know that that 3 is actually 3 times 3, which is 9, and the square root of 9 is 3, and that gets to come out as 3, and that 2 that's still there that doesn't have anybody to partner with gets stuck on the inside. So that's kind of a shortcut way to work through this process. So let's do a few more examples. Okay, so this one is the square root of 8, and the square root of 8 can be written as a product of prime factors because 2 goes into 8 4 times. 4 is not prime, 2 goes into it 2 times, and since 2 is prime, I know I'm done. So the square root of 8 is the same thing as the square root of 2 times 2 times 2. Now I still need to circle in groups of 2, so I can only take this set right here. That 2 is what will get to go outside the radical, and this 2 stays in. And so that one's done. That one's simplified. Okay, this one seems a little more complicated just because the number is a little bit bigger, but it's really not. If we take the square root of 48, and we take 48 and write it as a product of prime factors using the ladder method, I know that 48 is even. 2 goes into 48 24 times. Half of 4 is 2, half of 8 is 4. 24 is not prime, 2 goes into that 12 times. 12 is not prime, 2 goes into that 6 times. 6 is not prime, 2 goes into that 3 times, but 3 is prime, so I know I'm done. The square root of 48 is the same thing as 4 2's and a 3. So for this problem, I can actually circle 2 groups of 2. And so both of those 2's get to come outside of the radical, and the 3 that doesn't have a group stays in. Now those 2 2's that we brought out need multiplied back together. And 2 times 2 is 4. So the simplified radical is 4 times the square root of 3. Okay, a couple more. Okay, now this problem, if you're really on top of things, you already know the answer to this problem, because 144, the square root of 144 is a perfect square, it's 12. So I know that's the answer. But if you're not quick on your feet, if you don't recognize that as a perfect square right away, this method still works. 2 goes into 144 72 times, 2 goes into 72 36 times, 2 goes into 36 18 times, 2 goes into 18 9 times, 3 goes into 9 3 times, 3's prime, you know you're done. So the square root of 144 is 1 2 3 4, 4 2's and 2 3's. 1 2 3 4 2's and 2 3's. So I've got this set of 2's, I've got this set of 2's, and I've got this set of 2's. And so what happened is everything got circled into a group. And so each of those things gets to go out. That's the first 2, that's the second 2, and that's the third 2, with nothing left inside of a radical. And 2 times 2 times 3 is 12. So we're going to get that answer anyway, even though we knew what it was in the beginning. It still works. When everything gets circled, there's no radical left. It was a perfect square. Okay, this one, great big number. Square root of 320 as a product of prime factors. Well, 2 goes into 320 160 times. 2 goes into 160 80 times. 2 goes into 80 40 times. 2 goes into 40 20 times. 2 goes into 20 10 times. 2 goes into 10 5 times. 5's prime, we're done. So we've got 1 2 3 4 5 6 2's this time and a 5. I can circle sets of 2's. So 3 of the 2's get to go out and 5 stays in. Those 3 2's multiplied back together make an 8. Okay, one more problem. Okay, this one, square root of 150. Okay, let's write 150 as the product of prime factors. 150 can be cut in half. Half of 150 is 75, but 75 is not even, so I can't put 75 or 2 into 75. But 5 goes into that. 5's prime. 5 actually goes into 75 15 times. 15 divides by 5 with 3 left, and 3's prime, so I know I'm done. 150 as a product of prime factors. Now I'm going to list these numbers in order numerically. There's a 2 and a 3 and 2 5's. That way, when I've got a group, I can just circle them right next to each other. I don't have a group that's separated. And so in this problem, that 5 gets to go out. But on the inside is left a 2 and a 3. Those two things, just like if they were on the outside, get multiplied back together, even though they're on the inside. And so the simplified version is 5 times the square root of 6.